Hi, good day. My name is Maris Johncy. And now I'm gonna discuss the transformation of geometry. Why is it important to understand the geometric transformations? So first, geometric transformation of shape is a change of its size, orientation, or position following certain techniques in mathematics. And the original is called the object, and the new shape is called its image. So, geometric transformations are operations that change the position, size, or orientation of, for example, orientation of a shape in a plane. They help us understand how figures move and relate to one another in geometry. These transformations are widely used in art, design, architecture, and even computer graphics. So here are the types. There are types of transformations of geometry. First, we have translation. Translation is a transformation of an object where every one point of it moves a fixed distance in a given direction. It means a translation moves a shape from one place to another without change its size or orientation. Example, sliding a triangle 5 units to the right and 3 units up. Second is we have a rotation. Rotation is a transformation of an object by rotating about a given through a given angle. So basically, rotation is returns a shape around a fixed point called the center of rotation. Rotating, for example, rotating a square 90 degrees clockwise around the origin or triangle. Next, we have reflection. It is a transformation of an object where every point of it and its image are the same distance from the line of symmetry. So it flips a shape over a line called the line of reflection to create a mirror image. For example, reflecting a triangle over the x-axis. Next is we have a glide reflection. It is a composition of translation and reflection in a line parallel to the direction of translation. It's just like a reflection, but it's in a parallel position. Next is we have dilation. Dilation is a transformation of an object by resizing to either reduce it or enlarge it about a point with a given factor. The value of factor determines whether the dilation is an enlargement or deduction. No, it's changes a dilation changes the size of a shape but keeps its proportions the same. For example, enlarging a triangle by a scale factor of 2. In conclusion, geometric transformations are essential in understanding how shapes and figures behave in space, and they connect mathematics to real-world applications, enhancing both creativity and problem-solving skills. Next is we have patterns and diagrams. So patterns and diagrams are fundamental in mathematics for understanding the modern world by providing a framework to recognize, describe, and predict regulatories in nature and man-made systems. So patterns and diagrams are important tools in mathematics that help us recognize, order, relationships, and repetition in shapes and numbers. Patterns can be found everywhere in nature, art, music, and design. Diagrams, on the other hand, are visual representations that make mathematical ideas easier to understand. So, pattern is a repeated or organized arrangement of shapes, numbers, colors, or symbols that follow a certain rule. Patterns can be geometric, numerical, or visual. While diagram is a simple drawing or sketch used to explain or show how something works or looks, diagrams help visualize shapes, patterns, and relationships in geometry. Next is we have symmetry. Symmetry is applied in a wide range of fields, describing objects and patterns that remain unchanged after transformations like reflection, rotation, or translation. This mathematical concept is used to create and analyze everything from the intricate designs of computer-generated imagery and the architecture of buildings to the patterns found in nature, such as snowflakes and the eddy. So symmetry is one of the most beautiful and important concepts in mathematics and art. It means balance and harmony in shapes or designs. A figure is said to be symmetrical if it can be divided into two or more identical parts that match exactly when folded or reflected. Symmetry can be found everywhere in nature, buildings, patterns, and even the human body. It helps create the order and attractiveness in the world around us. As what I've said earlier, symmetry is a sense of harmonious and beautiful proportion of balance or object is invariant to any various transformations like reflections, rotations, or scaling, and it has two types of symmetry: bilateral symmetry and radial or rotational symmetry. So, bilateral symmetry is a symmetry in which the left and right sides of the organism can be divided into approximately mirror image of each other along the midline. Bilateral symmetry occurs when a figure or organism can be divided into two identical parts along central line axis of symmetry. Each half is the mirror image of the other. Like for example, if you draw a line down in the middle of a butterfly or a human body, both sides appear almost the same. And the second one is we have radial or rotational symmetry. It is the parts of the objects are arranged around a central point and it looks the same after being rotated. So radial symmetry is a type of symmetry where parts of an object or organism are arranged around a central point or axis. This means that the structure looks the same when rotated at certain angles. Radial symmetry is commonly found in nature, especially among flowers, sea creatures, and other organisms that live in water. It is also used in art, design, and architecture to create balance and beauty. So as you can see, it can also be found in snowflakes and also mostly in plants. Radial symmetry occurs when body parts or patterns are arranged equally around a central point. Any line down through the center divides the object into equal halves. In conclusion, symmetry is not just a mathematical concept. It is a reflection of beauty and order found everywhere in nature and human creations. Understanding symmetry help us appreciate the balance, design, and patterns that make the world visually appealing and structurally sound. Thank you so much and have a good day.